everybody, welcome to another My Tutor online school tutorial. Today it's GCSE Maths and today is about loci and constructing and finding loci. If you don't know what that means, you will do soon. So this session is 1 hour long, so it will finish at 3 p.m. And it will be led by me, Molly, who, if you've come before, you probably know me by now. I'm just finishing my second year of computer science and maths, and I've done over 200 lessons with my tutor. So we'll get going. Make sure that you use really good use of the Q&A and chat functions. So tell me if you want me to speed up, slow down, go over something again, any questions that you have, and also put your answers on there. Today it will be, because it's more like drawing, it will be slightly less easy to do so, but give it a go anyway. And also there's always a maths joke at the end, so if you want to send them in at any point. And someone's asked if there'll be a Kahoot. Yes, there will be a Kahoot at the end today. From next week, I'll be doing them at the beginning and at the end. Today, I haven't loaded up my my tutor space. Today it will just be one at the end because I haven't prepared it yet. Yeah. So today as well, because it's all about loci and drawing, if you want to kind of do along with some pen and paper, you'll need a pair of compasses and a ruler. I think that's everything, hopefully, and a pencil. So yeah, that's just if you want to draw along with me. Okay, cool. So let's jump straight into it. So loci, what on earth are they? What does it mean? So a locum, which is the singular version, is anything that follows a set of rules. So for example, we could have draw the locum of everything 5 meters from this point, and you draw all of those. And loci is the plural. So loci are saying shade the area that follows all of these rules. And that will make sense what I'm on about more and more throughout the session. Someone's asked if we need a calculator for today. No, absolutely not. Today is pretty much just drawing and shading things. Okay, so there are 4 different types of key loci that we're going to look at. And I'm going to go through them one by one, and then we're going to look at some combined questions. And then we'll do the Kahoot. So the first one is shade the points that are within 5 meters, or let's do 5 centimeters so that you can draw it. You don't want to be doing 5 meters from A. So let's call this point A. And we want to draw everything within 5 centimeters from it. Someone said, what's the locus? Is it the point? No, the locus is, so I'll kind of, in each one, I'll tell you what the locus is, if that makes sense. It's quite hard to say without doing an example. So does anybody have any ideas about what we can draw to find all of the points that are within 5 centimeters of here? Yeah, a couple of people have already got it. So for this one, it's going to be a circle of radius 5 centimeters. And that's because, for now, let's forget about the within. Let's just think about the points that are exactly 5 centimeters from A. Well, obviously, this is going to be difficult because I don't have a ruler, that it's not going to be precise, but you'll get the idea. So they're going to be, you know, say this is 5 centimeters and this is 5 centimeters and this is, and you can do that all the way around. And what you'll see is that it will form a circle around this point. And this circle has a radius, trying to get that in the middle, there you go, of 5 centimeters. So hopefully that makes sense, because then everything on this line is exactly 5 centimeters away from A. That's a good point, actually. Is there a... No, there's no ruler on that. So if you want to have a go at drawing it, you would measure out your compass to so that the pencil is exactly 5 centimeters from the pin. Put the pin on the point A and just swing it round. And that's how you do that one. This is quite an easy one to actually construct. Some of them get a little bit harder. Oh, someone said my video just froze. Hopefully that doesn't happen again. So then if we want to shade all of the points that are within 5 centimeters, it's going to be everything that's within this circle. Because that means that it's everything up to 5 centimeters away. Anything outside the circle is going to be more than 5 centimeters away. Whereas everything inside will be within that 5 centimeters. Okay. So sometimes if this is in a word question, it will be something like, I'll draw one out actually. It will be like, a horse is tied to a post. So like and a horse is tied to a post. I'm not going to draw a horse. I'm going to draw the horse as a box with a rope of length 4 meters. And the locus, by the way, sorry, in this case is the circle, because that circle is the set of points that follow the rule that they are 5 centimeters from A. So that's what that locus is. So here it's draw a locus of where the horse could move. And the furthest that you can get, if you imagine that rope being pinned to the center there and the horse moving around as far as he can, the horse is going to make a circle of radius 4 meters. So that's exactly what you do. Like this. That's where the horse can go. And the horse could also go anywhere inside because he could make the rope more slack, like move towards the post. So the kind of shaded area here is, again, everything within this circle. So that's an example of a kind of word question that you might get. Some people are saying that they can't see me, but it's on the Q&A, so I don't know whether that's just one person saying it or... Anyway, I'll carry on. Someone's asked for a formal explanation of how to do this type. Sure. You won't always need these. I think you can normally just kind of draw them. But so the loci of distance x from a point is a circle, radius x, center the point. Hopefully that makes sense. So the loci of, say, distance 3 meters from a point is a circle, radius 3 meters, centered at the point. So that's a formal explanation for this type of locum. Okay, so the next one is going to be a perpendicular bisector. Sounds kind of scary, but it's not. So we'll break it up. Perpendicular means that it's at a 90-degree angle, and a bisector means that it exactly cuts a line in half. So if we have 2 points, A and B, so A and B, and we draw a line between them. Ooh, it's very difficult. That'll do. And we want to draw the perpendicular bicenter. So the line that, so I'll draw what it approximately looks like. The line that kind of looks like this, a bit further across. So it's perpendicular to it and it cuts it exactly in half. And I'll explain in a moment like why we might want to do that. So the way that we draw this is okay. So again, this is going to be quite difficult to explain without kind of showing you. But so what you're going to do, you're going to take your pair of compasses and just extend it so that it's over halfway across the line. So its length is more than half of here. And then you're going to put the pin here and just draw like a little bit of a circle here. So just a little kind of arc of a circle up here. Then you're going to do the same at the bottom. So with the pin still on A, you're going to draw another little arc of this circle down here at the bottom. Then you're going to put the pin on B and keep it the same length, draw a little arc of the circle here and a little arc of the circle down here. And then what you do is you see where these cross over, it makes like an X at the top and at the bottom. All you're going to do is join up those to the center of those 2 points. Clearly, I didn't draw it very accurately, but this will be a right angle here, and it will bisect it exactly in half. Okay, a load of different people are telling me that they can't see me. As long as you can hear me, that's the main thing. Like, I'm not really doing anything. Yeah, just by seeing the screen and hearing me should be enough, because I don't really know how to fix that. Let me just try turning it off and on again. Classic. Maybe that fixed it. Okay. Okay, that might have actually fixed it. Right, so this is what's known as a perpendicular bisector. So as I said, it's perpendicular because it's at 90 degrees, and it's a bisector because it exactly cuts this line AB in half. And the reason that we might want to do something like that is the question might say, draw the locum of points that are an equal distance from A and B. And that's exactly this line. If you kind of think every point on this line is the same distance from A, like straight line distance, as it is from B. Anything either side of this line is going to be closer to either A or B. So that means if we had a question that said, because a lot of these are about shading areas. So if we had a question that said, shade the area of points closer to A than B, then we would draw this locum and shade everything on this side. Because everything on that line is equidistant, the same distance from A as it is from B. Everything on the other side is closer to B. So everything on this side is closer to A than it is to B. Okay. So that's that one. Like I said, I'm only going to go through all of these once in the explanation, but then we're going to do a lot of practice with combining them and stuff. So this next one is a perpendicular line from a point to a line. I'll explain what I mean. So if we have a line like this, and we have a point here that we'll call P. Basically, this is how to construct a line like this that's exactly perpendicular. Obviously, I could just do that because I can see it on the screen, but this is a way of showing like exactly how. So what you do is it's really, really similar to the previous one. You're going to take your compass and put the point on here and put your pencil on P. And just, so I'll do this in grey to show you, and just do, you can do a little bit of an arc if you want to, show that you're at P, and then keep that same length and do a little bit of an arc at the bottom. And then from B to P, that length, do a little bit of an arc if you want to. The main thing is that you do a little bit of an arc at the bottom. And then we can again see this is exactly the same as before. The reason that we're doing it from A and B to P is because before we were trying to get it exactly midway, so we kept the length the same for each one. But now we're not trying to do it midway, we're trying to do it from wherever P happens to be. So we make our compass just the length from A to P or from B to P. And then we connect up these lines. These are like points with a line. Again, I haven't done it very accurately, but this will be a right angle here. And you don't actually need this bit at the bottom. You can just draw it up to there. And that's a perpendicular line from P dropped down to the line. Okay. One really, really key thing, if you're doing this in an exam or for a homework or something, make sure you leave all of your construction lines on. So if you're doing one like this, leave on this little X here. And for this one, leave on both of the crosses here. Even though you might think it looks messy, If you don't, the teacher might think that you've just done it some other way and got lucky. So you've really got to leave all of your working on there so that they know that you've used your pair of compasses correctly and that you've done the construction in the right way. Someone's asked to re-explain this one. Sure. I'm going to just label these A and B. I'll just do it quickly because when I go through questions, I'll be re-explaining it as well. So you put the pin of your compass on A and the pencil on P, and keeping it that length, draw a little line down here. Put the pin on B and then the pencil on P, and draw a little line down here. And where they cross, put your ruler between these 2 points and draw your line, and that will be at a right angle. So that's a quick little explanation there. I can't actually think of an example question at the moment of when you would use this exact thing, like, you know how I came up with example questions for these ones. But if we see one, then I'll let you know that that's what it is. Okay. Let's have a look at the final one. This one is the hardest, but also one of the most interesting. This is an angle bisector. So again, let's break down what that means. Angle, we know what that means. A bisector, same as before, it's going to cut the thing in half. So whereas a perpendicular bisector cuts a line exactly in half, an angle bisector cuts an angle exactly in half. So I'll show you again an example of a question that this is really useful for. So first of all, let's just draw a couple of lines that make an angle. So like this. Okay, and let's say we want to draw the line that's an angle bisector here. So what that means is, I'll just kind of do it in a sketched way, a line that probably is going to look a bit like that, because you see how it cuts it so that, say the angle is 40, each bit is 20. Now, the way that we're going to do this is, as I said, it's a little bit harder, only because it's one extra step. So you're going to get out your pair of compasses again and put the pin on here at the point of the angle where it's formed. Then you're going to stretch it out. It doesn't matter how much, just kind of maybe to about here, and draw a little curve. And keeping it the same length, draw a little curve that crosses this line. Then keep it the same length, move the pin to the cross that you just drew. So where our grey pencil line crosses the line here. So this is where you put your pin first. And now this is where you're putting your pin, and here. And keeping it the same length all the time, put the pin on and draw another little cross here. And again, the pin on here and draw a little cross here. And now you see how we've got where these cross. You're going to draw a straight line from our original point to now where this new cross is there. And you see, again, this isn't perfect because obviously I haven't actually used a pair of compasses, but now you can see that this looks like our angle bisector, and these two angles here will be identical. Hopefully that makes a bit of sense. Like I said, I'd really encourage you, if you have a pair of compasses with you, then I would really recommend using that. Somebody's asked how to draw a good circle size with an actual pair of compasses. I don't actually think I have any, at least on me. That's quite bad. No, unfortunately I don't, but I'm sure there are plenty of videos on YouTube and the like where we can kind of see how to draw a nice one. The key thing is just to make sure that the tip of your point and the tip of the pencil kind of lie flat when you put them on the paper. Then draw it to whatever length, pinch it at the top and kind of swing it around, like twist it like this. There are loads of videos on how to draw a neat circle and arc bits with a pair of compasses, so feel free to watch some of those. Someone's asked me to re-explain this one. Sure, that's fine, because I know that this one can be really quite difficult. First of all, I'm just going to explain why we might use this one. So I'm just going to label our points here. So we're going to call this point at the angle A, and we'll call this B and this C. I'm just going to actually extend this line a bit further to show you something. So I'm just going to extend it to, I'll just extend it out to here for now. So the question here could be, draw the locum of points equidistant from the lines AB and AC. I'll explain this, don't worry, I know there's a new word in there. So when we did this one, this was the locum of points an equal distance. Equidistant just means an equal distance from. Just makes you sound a bit fancier. So this line is the locum of points that are an equal distance from A and B, where A and B are points. Now this is the locum of points that are equidistant from two lines. So when it's 2 points, you draw a perpendicular bisector. When it's 2 lines, you draw an angle bisector. Oh, apparently my video's disappeared again. I'll do what I did before and turn it off and on again. Computer science student. As I said, don't worry if you can't see me though. The main thing is that you can see the screen and hear me. Okie doke. So hopefully this will make sense. And just as a brief explanation again, if you can hear banging, that's my washing machine, sorry. So what we did was we put our pin here and drew little arcs cutting both of our lines. Then we moved our pins to our little arcs and made another little cross here, and then connected our line from the first one up to here. Okay, I'll explain them more as we do questions anyway, but these are the 4 main ones. So that's not too bad. We've got the circle, points equidistant from a point. We've got the perpendicular bisector and the perpendicular line, which is points equidistant from 2 points. And we've got an angle bisector, points equidistant from 2 lines. So this kind of covers most of the kind of stuff that we need to know. Somebody said, what about the triangle with 60 degrees? I don't know exactly what you mean. Sorry. If you can rephrase that. Okay, let's just go to some of these questions. So again, shock horror, I'm using Math Made Easy, and this also has a really great explanation of them all. So I wanted to use this example with a pre-drawn diagram for you to show you the kind of questions that we're going to be looking at. So this one is points A and B are 6 centimeters apart. Shade the locus of points that are closer to point A than point B, but less than 4 centimeters from point B. So this seems quite overwhelming. Someone says, are you getting paid for using Maths Made Easy? I wish. Okay, so all we do when there are 2 locum, so rather 2 loci, we just draw each of them and shade the area and see where they overlap. So I'm going to show you this in my kind of horribly drawn diagram, and then I'll paste on the one from the website, which is a lot cleaner and nicer to see. Oh yeah, someone said there's a loci where you have to construct a 60-degree or 45-degree angle and it makes a triangle. I don't actually know that one, but for a 45-degree angle, you draw a line, draw a perpendicular bisector, and then do an angle bisector, and that will give you a 45-degree angle. Hopefully that makes sense. For 60 degrees, gosh, I'm not 100% sure actually. I can look into that for you though and tell you at the beginning of the next session. I don't think they're as common, but maybe they are. Maybe they are. So let's have a look at this one. So the first thing that we do is, obviously you can do this if you have like a pen and paper and a ruler. Try this one, you will be able to do on paper because it you can measure 6 centimeters. I'm just gonna like be guessing on here and drawing it as accurately as I can. So points A and B are 6 centimeters apart. So I'm going to draw a line between them. We'll pretend that this is our, let's do it like this. This is our 6 centimeters. Point A and point B. Shade the locus of points that are closer to point A than point B, but less than 4 centimeters from point B. So let's take this one at a time. So closer to point A than point B. So closer to here. So that means a perpendicular bisector, right? Because we want something closer to A than B. So it's going to be everything kind of on this side of halfway. So let's remember how to do our perpendicular bisector. We take our pair of compasses and we're going to put the point at A. And then we're going to stretch it out so that the pencil is more than halfway along this line. So let's say here, where this grey dot is. So our pin is on A and our pencil is here. And then you kind of move it and draw a little bit of the arc of the circle up here, wherever that kind of goes. So this is a circle, radius this, center here, like a little bit of it. Keeping it the same length, we do an arc at the bottom, so like here. And then we're going to keep the same length, but move our pin to B. And do the same thing. A little bit of an arc of this circle up here, and a little bit of the arc down here. And then we're going to put our ruler so that it's between this point and this point, where these kind of things make a cross. And then we draw a line. I'll do it in grey actually, so that there's not too much going on. We draw a line connecting up these points. And you see how this has chopped the line in half at a perpendicular kind of an angle there. Okay. So let's think about which points are closer to A than B. It's everything on the left-hand side of this line, right? Because everything here, so I'll underline which bit I'm looking at, closer to point A than point B, is everything here. Now we could extend this further. This could go down further and out further, because anything way over here is of course closer to A than B. But we'll do that for now and only expand the shading if we need to. So now let's have a look at less than 4 centimeters from point B. So remember, that's a circle. And if you get stuck, just try thinking of some things that are exactly 4 centimeters from B. So let's say here, 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 and so on. So key thing here is that A and B are 6 centimeters apart. So this is 3 centimeters. So 4 is going to be about here. Because what we're going to do is put the pin of the compass, if you're doing this along with me, put the pin of the compass on B. Well, before you do that, stretch it out and measure 4 centimeters between the pin and the pencil of your pair of compasses. And then place it down so it will land, I'd say, around here, where I've just drawn this red dot here. I don't know why my washing machine does that, I'm sorry. And then we're going to draw a circle around B with that as its center. So I'll do this in grey. So this is going to be quite difficult to get accurate. Hey, you know what? That's not too bad. So this circle here, right? So this has got radius 4 centimeters because everything on this locum here is exactly 4 centimeters from B. So what area is less than 4 centimeters from B? Well, it's everything within this circle, because anything outside is more than 4 centimeters. So it's everything inside this circle. Now, what this question is asking us is for everything that is both of these things. So both of these things is where they intersect. And the only place where both of these things are true is in this little segment here. Right? So everything there, it's closer to A than B because it's on this side of the line, the perpendicular bisector, but it's less than 4 centimeters from B because it's still within this 4 centimeter circle around B. And we can see that in a much nicer way here. See how now they've done actually full arcs rather than just like a little cross and a little cross. That's up to you. So these are their construction lines. So you see how it's on this side of A, but it's still within the circle for B. Let me know if that doesn't make any sense. But yeah, cool. We'll have a go at some more. Okay, let's have a go at someone here. Oh gosh, this is a... Well, that's a horribly scanned document. Let's not do that one. Better. Okay, not what we want. Why are all of these just accurate drawings? Oh yeah, so here there's actually a question to construct an equilateral triangle. Let me just have a quick look for you because, as I said, I didn't know that that was a thing on the specifications, so thank you very much for bringing that up. So let's have a look together at how we do it. I see, okay. Yeah, I can definitely explain this one. So we want to construct an equilateral triangle. So here's what we're going to do. let's say we want our triangle to be 6 centimeters, if you're drawing this along with me. So we're going to draw the base as 6 centimeters. So there's the base of our triangle. Now, what's true about an equilateral triangle? Well, all of the side lengths are the same. So we're going to set our the radius of our compass, so the distance between the point and the pencil, we're going to set that to 6 centimeters. So put the pin here and the pencil here, and draw a little arc at the top. So kind of about here. Because what that tells you is that it's going to be 6 centimeters from here, because it's got a radius of 6, right? So anything kind of within this arc, this has got a radius of 6. And then we're going to do the same from this point. So keep it at 6 centimeters and now put your pin over here and draw a little arc at the top. And that's going to be the peak of your triangle, because this arc tells us that it's 6 centimeters from here, and this arc tells us that it's 6 centimeters from here. So then all you have to do is draw a line from where these cross over, so where I've just done this little red dot, the center of there. We're going to just draw the line from here, down to here, and down to here. And that's an equilateral triangle, because all of the side lengths are the same, and because all of the side lengths are the same, it's equilateral. Therefore, all of the angles are the same. So this is actually how you do a 60-degree angle. You just make sure that you draw two sides that are the same. So hopefully that will make sense. I just got 4 messages in a row. 2 said to slow down and 2 said to speed up. Okay, I'll just go on to another question. Let's see. Okay, that's an angle bisector. Making some accurate drawings of things. Okay. Those aren't the kind of questions. I might have to come up with some questions myself, to be honest, because of what I want based on what's in the Kahoot. Yeah, okay, so we can just get something as simple as this, which just tells us, so you've just got to know the difference between saying a locus and like an area. So the locus is just, for example, here, points which are equidistant from both of them. An area would be on one side of that, so closer to A than B or closer to B than A. So for here, remember, equidistant from 2 points, we're going to draw a perpendicular bisector. Someone's asked how you would construct a 30-degree angle. You can do that by constructing a 60-degree, like I just showed you, and then doing an angle bisector. So you can make a load of different angle lengths. Okay. So what we're going to do, I'll try to do this one a bit quicker. We're going to put our compass here on A, and just extend it so that it's over halfway, and draw a little, it's going to go over the text, a little arc at the top, a little arc at the bottom. Then put the pin on B and do the arc at the top, the arc at the bottom, and connect the two together from the points there. That's very poor. That's clearly not quite a right angle, but it would be. If you do it on paper and do it properly, then that will be. Okay, so that's that one. They can then obviously get a little bit harder. For example, let's have a look at this one. Here it says, oops, sorry, losing which tab I'm on, that we want to draw the locus of points that are exactly 4 centimeters from this line X, Y. So this is a really interesting one. So if you think about that, that's going to be like kind of 4 centimeters above here, 4 centimeters here, and then it will do something interesting at the edges. So we'll think about that. Let's first of all think about the ones that are directly above and below. Basically, all we need to do for that is we're going to start off by drawing, so it doesn't have to be a bisector, but we may as well. We're going to do a perpendicular bisector. So that's exactly like we did before. We put our pin on X and draw some arcs. Ooh, that was poor. Put our pin on Y and draw some arcs. Connect up where they cross. I'm just going to pretend that the center of that was there so it's a bit better. And then we're going to use our ruler and mark 4 centimeters on these. So 4 centimeters above, 4 centimeters below as well. And then holding our ruler against XY and just moving it down so that we can draw some parallel lines. I'll do the final locus in blue. We draw a line that's along that 4 centimeters, so parallel to XY, but we know now that it's exactly 4 centimeters away. And then we do exactly the same for this top one here. We'll pretend that that's on the 4 centimeters. And then at the edges, well, we want it to be exactly 4 centimeters away from the line XY. Well, that's the same as saying, when we're at the edge, it's the same as saying exactly 4 centimeters away from X, because that's like the only bit of the line that it can kind of see, if that makes sense. So all you're going to do is hold your pair of compasses, put the point here and the pencil here, and swing it around until you join up to this. So this can only go wrong. Is there an arc function for me to draw? Nope. This is going to be awful. Put the point here and just swing it around until we get to here. Hey, that could be worse. That actually looks quite accurate. And then we do exactly the same on the other side. Put the point on Y and the pencil at the top here. And swing it around until we get, oh, that was a lot worse. Swing it around till we get to here. There you go. That's not bad. And that's what this locus looks like. And if you kind of think about it, all of the points on that are exactly 4 centimeters from this line, XY. And see, the only construction that we actually had to do there was finding the bisector so that we could measure exactly 4 centimeters away at a right angle. Then we could draw parallel lines and just finish it off with some circles at the edges. Someone said, what does equidistant mean? That means an equal distance. So if something's equidistant from X and Y, it's the same distance from X as it is from Y. Okay, what time are we on? Cool, cool, cool. Okay, we're going to do one more and then have a go at the Kahoot. So I'm going to come up with one because the Kahoot is all of the questions. So this Kahoot, I put it together, but all the questions are from somebody else. And they're all about, so they're a shaded region. And it's like, what does this shaded region represent? So it might be quite difficult, but we'll have a go. But just to do one more. Let's do, okay, this is what we're going to do. I'm going to draw a nice little, some sort of quadrilateral here. And we want, so let's label these A, B, C, D. So here's what the question is going to be. Shade the region representing points closer to AB than AD, but within 5 centimeters from C. Okay, so again, this is 2 things to do. We're going to do both, shade them, and work out which bit is kind of in both. So first of all, let's take a look at this. Closer to AB than AD. So that's closer to this, wrong button, closer to this line than this line. And that's an angle bisector. So this is the hardest one. So we're going to put our point on A and extend it a little bit. In fact, I'll do all of this in blue so you know which construction lines are which. Extend a little bit, draw a mark, a little arc on each of these. Then move your pencil, not the pencil point, the point of the pair of compasses to these and draw some little arcs, keeping everything the same length. And then you go from the center of this down to here. And we're going to extend that line all the way up as much as we need to. So let's just do that much for now, just more than you think you're going to need to. In fact, I'm going to go even further than that. And I'm not going to shade it for now so that we can shade it more cleanly at the end, but closer to AB than AD is going to be anything on this side of the line, right? Because everything on this line is the same distance from both of these lines, but everything on this side is going to be therefore closer to this line AB. So we know that we're looking for something on this side of the line. And now we want within 5 centimeters from C. So this one's hopefully nice and easy. We're going to put our point of our pair of compasses on C. We're going to measure out 5 centimeters so that the point and the pencil are 5 centimeters apart. And we're going to draw, we're going to draw a circle with center C and radius 5 centimeters, whatever that may be. So let's go for here. Now, that's not quite center C, there we go. And now everything, we want to shade the region representing that. So the region of everything within 5 centimeters from C, remember, is everything inside this circle. So we want everything on this side of the line and inside the circle. So our final region is this kind of semicircle bit here. It might have also said and inside the quadrilateral, in which case it would be that tiny little bit or outside or whatever. Hopefully this makes sense. And I think it will make sense once you can give it a go, analysing them more when we have a go at the Kahoot, which I think we'll have a go at now. So, fingers crossed. Oh, I had it all ready and everything, and it's gone off the page of my Kahoots. Here we go, Loci. So all of these are, because I got them from a different teacher, they've all got a little cartoon of him on them. Okay. So grab your phones, either the apps or go to kahoot.it, and here's the game pin. Now I think this Kahoot is quite hard. I found it quite hard when I first did it, but the more you get into it, the easier it actually becomes. And we can always play it through. We can play it through once, and then I'll explain them a bit more, and then we'll play it through again to see if people have improved. If we want, we'll see what time we have and what everybody wants to do. So there are, someone said, can you put a link on the chat? Sure, it's just kahoot.it, but I'll put it on here, kahoot.it. And then just put, oh, I guess that's not a clickable link, is it? Does that work? There you go. I think if you click on that and put in this game pin, it should work. So there are 32 people here, so I'll wait until I have hopefully that many. Yes, some positive Molly-based nicknames today. Okay. Is anybody still waiting to come in? Just let me know in the Q&A or chat. Oh, some people are still joining. Someone's definitely trying to swear in their nickname because it's changing it to things like this. Anybody still waiting? I know that not everybody always joins these to play. Okay. Oh, someone just said that they're waiting. Okay. I'll give it just like 30 more seconds and then I'll start it. If you don't get a chance to join, don't worry. Just maybe write down your answers. See if you see what you can do. Doesn't matter. Just join if you want your score recorded. Someone said there's a limit to the amount of people in one Kahoot. The limit is a lot more than the people in here, though, I think. Okay, we'll just get started, I think. I'm sorry if you're not in the room, but just, yeah, get going. So we want to, for all of these questions, it's describe the shaded area that's going to be in the diagram. So here, I actually think that this is the hardest one, and it's the first one. So give it a go. You do have a minute for each one. I'll stop talking so that you can think. Actually, just a quick note, the yellow here is the whole part on one side of the, it kind of looks like the strip in between two circles. It's not, it's the whole of that kind of weird curvy triangle bit. Because that threw me. I got this question wrong when I practiced this. Okay, well done to the 3 people who got that one right. I expected this one to be the hardest, but I'll explain it now. So I think it's very off-putting because you have these curved bits here. That was just for their construction lines. They put the crosses inside the rectangle, which is a bit strange. But if you take a look here, is it closer to A or B? Well, it's on the left-hand side of the line. So it's really promising that most people put it on red or yellow, I think. Yeah, because it's definitely closer to A than B. So you can kind of narrow it down to a 50-50. And then we ignore these lines and just look at this one here, the curved one around A. That's going to be some distance from A there. And it's outside of the circle. So you can tell that it's going to be, even if you don't know what the exact distances are, you can tell that it's going to be at least some distance from A, because if it was within a distance, it would cover A itself. So that one is the hardest one, don't worry. Yeah, I feel like, yeah, there were definitely a lot of guesses on that one. But I think we'll kind of do this Kahoot twice, maybe, if we get a chance to. Hopefully they get a little bit easier from that one. Okay. I might skip. I feel like there are only 20 people in here. Oh. Almost skipped before someone had got their answer in. Okay, cool. Yeah, brilliant. Well done. So a few people put this. Where's the mistake there? So because you think it's at least 4 meters from the point P. I can see why, because it doesn't surround the point P. So the way that we can tell this, first of all, it's within the circle of P. The only reason it doesn't cover P itself is because it's restricted by, I'm pointing, like you can see me pointing on the screen. I don't even know if you can see my cursor, but it's restricted by the line here. So the line that is in the middle tells us that it's closer to L. And the fact that it's within the circle tells us that it's within a certain distance from P. Hopefully that one makes sense. Again, I feel like these scores will go up and up throughout the question. Well done to Z, who's got both of them correct so far. Okay. What about this one? Same diagram, different area shaded. Most people are getting them in a bit quicker as well, which is really good. Okay. Okay, cool. So at least, yeah, some of you got it. So I think, yeah, so it looks like the common mistake here was thinking that it was at least 5 meters from the line L. But we can see here that it's kind of close to the line L. So this whole thing at the bottom is the line L. So we see that this line is 5 meters. We just have to assume that from what the answers are. So it's on this side of the line. So it's within 5 meters from L, but it's outside of the circle. So it's at least something from P. That makes sense. So it's within 5 meters from L, but it's at least 4 meters from P because it's outside of that circle there. Someone's called themselves Maths Made Easy. I rate that. Okay, halfway through question. Another horrible diagram like the first. Remember that these are kind of, yeah, construction lines. Hopefully at least we can get the right, whether it's closer to A than B. Think about that first. Is this shaded area closer to A or is it closer to B? Okay, even though not everybody got that, I'm really, really happy that the majority of people went for this because at least you could tell that it was closer to A than B. That's a good thing to spot. So well done. The only reason, so the reason that it says that it's a bit trickier and it's actually within is because see this is the circle around B and it's actually within that. You see, the reason that it doesn't actually go all around B is because it can't, because then it would be closer to B. So it's within, don't just kind of think about it just as the distance, think about it in terms of the circle. So it's within that circle around B. Hopefully that makes sense as to where the mistake was there. Okay. Let's look at this one here. We've got a different type of locus here. Let's see. Like I should put on like the Wii waiting music or something. So for this one, just see again if you can work out, you know, which line is it closer to? Is it closer to AD or DC? So at least try to get the right one of those. And then think about, is it within the circle around A or is it outside the circle? Perfect, well done. Majority got that one, which is perfect. And the other majority here, the 6, at least still got that it was within 8 centimeters, and these 4 got that it was closer to AD than DC. So we see this line here, this straight line, is an angle bisector. So we can see that this shaded bit is closer to AD than DC. You see it's a lot, all of the shaded bit is closer to this line than here. And then we can see that this curve is this circle around A, and it's within that. So it's within the range of A. Okay. Oof. Bob's pulling through. Okay, 3 more questions left. Okay, similar looking diagram, but we don't have an angle bisector this time. We've got a perpendicular bisector. And the options are a bit trickier this time. Okay, so well done. At least all of these people who got it here saw that it was closer to AD than BC, which we can see there. And then remember, we're talking about its distance from A, and it's within the circle. That's what you've got to think about. Kind of ignore the others for now. This shaded bit is within this circle from AC to AD. So it's within 10 meters of A. Two more questions. Let's have a look at this one here. So this diagonal one is interesting because you've got to work out what on earth this one is actually telling us. So this is quite a tricky one, but you can narrow it down to 2 by looking at this circle. So is it within the range of D or is it outside the range of D? What do you think? Okay. Oh, well done. Majority got this one. Congrats. So, and the other good thing is that most of the other people put this one. So at least 12 meters from D. So yeah, we can see this circle here. See, it's on the outside of the circle. So we know straight away it's got to be at least 12, at least, sorry. Yeah, 12 meters from D. And then this line here, you kind of got to ignore the box and just think about A and C. This line is the one that's equidistant between those points. If you imagine a line joining these, it's our perpendicular bisector, isn't it? And it's on this side, so it's closer to A than it is to C. So well done for getting that, because most of you did, so that's really good. Last question, you're almost free. Okay, final one. Similar, here again, we've got a circle, so I think you can narrow it down to 2, decide whether it's within the circle to D or outside the circle to D. And then look here, we've got some sort of perpendicular bisector. So think about what that's telling us. The math joke is coming, don't worry. Look at that. Yes, guys. Improvement by the end. I love it. Incredible. So yeah, it's closer. It's within the 6 meters from D because it's within this circle here. And then we see this line is a perpendicular bisector of these. So it's closer to BC than it is to AD. So well done, everyone. That was really, really good. Someone said, can we do another Kahoot? Yeah, I really kind of wanted to do this one again, but unfortunately we have 1 minute left. So unfortunately not. But yeah, I hope that everybody kind of enjoyed that. Let's have a look at the results. Sorry, we've got to see who won. Mr. Hegarty in third, Bob in second, and in first. Dun, 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 dun. Raised eyebrow emoji. We got 6 out of 8, so that's incredible. Well done. But yeah, the best part of that was that the improvement of the percentage of people getting it right towards the end. So I really hope that that helped. I'll go on the get feedback. So yeah, feel free to feedback. So thank you all so much for coming today. Maths joke before I go into my end spiel, otherwise I'll forget. Not linked to today's thing because I couldn't find one linked to Loci, but why do plants hate maths? Because it gives them square roots. I've had that one sent a few times and I really like it. So there you go. Thank you all very, very much for coming today. I hope it helped somewhat. Do check out the My Tutor websites if you're interested in one-on-one tutoring. That can be super, super helpful. Just check it out, and there's a really easy system for matching you with a tutor. Check out also the timetable for next week. As soon as that comes out, all of the 1 hour, these live sessions. And I think I will see you next on Tuesday for another session. So thank you all very much for coming. I feel like a YouTuber signing out. Make sure to like and subscribe. Oh yeah, do check out the My Tutor YouTube channel. I'll stop waffling. Thank you all very much for coming. Have a fantastic day, and I'll see you next time. Bye, everybody.